Hi, I'm Assalamualaikum and we are from Group 4 will be present the experiment 1 which is Marcet boiler. And our team member include with Lokman Hakim and me from Syafiq, Hussein Dalma and Nur Anis Nazura. And now I will be through with the introduction first, which is the abstract. The Marcet boiler experiment is to determine the relationship between the pressure and temperature for a certain system. When the pressure increase, the temperature will increase because the pressure is directly proportional to the temperature. From the data we use from the direct formula and data, we can get the slope of the graph that can be calculated. And the dt over dp that was calculated is then compared with the data in the stream table. The value from the stream table should be almost the same with record value. So from the experiment, the different in reading is due to some error that were made during the experiment. So the objective of this experiment is to observe the relationship between the pressure and temperature for saturated system. And now we will proceed about the introduction of this experiment. Thermodynamics is a physical branch that studies the interaction of energy between a system and surrounding that occur when the system undergoes a process. The change in property of fluid also is the concern in thermodynamics. Most of the substance in thermodynamics are often referred as the PVT substance. For an ideal gas, it obeys an equation of state that relates the pressure, density, or specific volume. Unlike ideal gas, real gas does not obey the equation of state. When the energy in water increases, the activity among the molecules will be increased that enable the molecule to escape from the surface until it is equilibrium, or known as boiling point. The state of equilibrium depends on the pressure in the surface of the water. Less energy is needed to achieve the state of the equilibrium when the pressure is low. Now I will proceed about the theory and related application. Thermodynamic properties of a pure substance could be determined by two of following characteristics: temperature, pressure, enthalpy, volume, and other characteristics. Data characteristics could be obtained either from experiment or equation or using certain. Among two thermodynamic properties that easily measured are T and P, which is T is temperature and P is pressure. Relation between these properties could be expressed in the form of graph or equation. Clapeyron equation has published the following. As you can see from the formula, which is Vf volume of water, Vs volume of steam, Hf enthalpy of water, enthalpy of steam, and heat domain of evaporation. Now I will be pass the presentation to my member.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So I will present about methodology. So firstly we go to with the apparatus. So this is the apparatus for the Marcet boiler. So the number 1 is pressure transducer. Number 2 is pressure indicator. Number 3, temperature controller or indicator. Number 4, control panel. Number 5 is bench. Number 6 is Bourdon tube pressure gauge. Number 7, temperature sensor. Number 8, pressure relief valve. Number 9, heater. And the last one, number 10, is water inlet port and valve. Okay, we move to experiment procedure. So we go through with the first, with general startup procedures. So number 1 is a quick inspection was performed to ensure that the unit is in proper operating condition. The unit to the nearest power supply connected. The water in the boiler is checked whether it was filled or not. Number 4, the valves at the feed port and the level side tube, which V1, V2 and V3 was open. Number 5, the boiler which distilled water to the feed port was filled and the water level is at about the half of the boiler's height was mature. Then the valves V1 and V2 at the level side tube was closed. Number 6, the power supply switch was turned on. And then the experiment now is ready to carry on. So, general shutdown procedure. The main switch and the main power supply was switched off when it has dropped to room temperature. The water for next use was retained. The upper part of the level side tube V3 was open to drain the water, and the valves V1, the valves V1 and valves V2 was open to drain out the water. So we go through with the experimental procedure, the real. Number one, the general startup procedures was performed. Initially, the boiler was filled with the water. The valves at the level side tube V2 and V3 were open to check the water level. The distilled water was poured in additional if necessary, then the valves closed. The temperature controller was set to 185 degrees Celsius, which is slightly above the expected boiling point of the water at 10 bar, which is ABS. Then number 4, the vent valve V3 was open and the heater was turned on. Number 5, the steam temperature rise observed as the water boils. Then the steam was allowed to come out from the valve V3 for about 30 seconds, and then the valve was closed. This step is important to remove air from the boiler, as the accuracy of the experimental result will be significantly affected when air is present. Number 7, the steam temperature and pressure was recorded when the boiler is heated until the steam pressure reached 10 bar. Then the heater was turned off and the steam temperature and pressure began to drop. The steam temperature was recorded when the boiler was cooled until the steam pressure reached the atmospheric pressure. And number 9, the boiler was allowed to cool down to room temperature. And lastly, the steam temperature was recorded at different pressure readings when the boiler is heated and cooled. Okay, that's all. Thank you.
Hi, Doctor. My name is Hussein, and this is my part of the group experiment. And then we are group 4. So, and this is our experiment 1. This is how I did the calculations. Curve pressure bar and absolute pressure bar, increasing temperature, decreasing temperature, mean and dV/dt, absolute pressure, mean temperature, Vt, Fj, and calculated slope, measure slope, percentage error, and absolute pressure as the group pressure plus 1, like 0.5 plus 1 is 1.5, and then increasing pressure and decreasing pressure I added and divide by 2, and then I got mean. So continue calculations. Sample calculating the percentage of error. Percentage of error is equal to measure slope minus calculated slope divided by calculated slope times 100. And we this equation we got 10.83 percentage, and this is sample calculating for specific volume Vg, and x minus 1.694 meter cubic divided by kg divided by 0.8856 meter cubic per kg minus 1.694 meter cubic per kg, and got 1.2898 meter cubic per kg. So sample calculating for enthalpy will be HFJ, and we got 2230 kj and divided by kg. TVG divided by HFJ, 382.65 K times 1.2898 meter cubic divided by kg divided by 2230 kj and divided by kg is equal to 0.2238 meter cubic K divided by kj. So next, absolute pressure bar, increasing temperature, decreasing temperature, and graph pressure against the temperature for heating and cooling process. Absolute pressure is an increasing pressure temperature, decreasing temperature. When absolute pressure goes down, temperature will go up. And next slide, graph pressure against temperature for heating and cooling process. Absolute pressure, increasing pressure, decreasing pressure. Whenever absolute pressure goes down or is down, temperature will increase. So this is my part. Thank you.
Okay, my name is Nur Anis Nazura binti Sharul Azli. I will present about the discussion part for this experiment. I will discuss about our observation during the experimental conducted and also the plotted graph, and I will indicate the relationship between the temperature and pressure of steam. Okay, the two curves on the graph were plotted for both heating and cooling process. Before the experiment conducted, we have to make sure that pressure is at 0 and temperature of water is at room temperature. We have to make sure to remove the air bubble from the boiler because it might affect the accuracy of the experimental results. If the air bubble is not removed, the correct equilibrium measurement between the steam and the boiling water will not be obtained. Okay, for both curve 1 and 2, their curve is quite similar due to the increasing rate of temperature during heating process is about the same as the decreasing rate of temperature during cooling process. We can see that from the graph, the cooling curve is a bit lower than heating curve. Why? It is because cooling process required more time as water cooling slower than heating up. Because there is no presence of catalyst to fasten the cooling process. So from the graph, we can conclude that pressure increased as the temperature increased. So the relationship is the pressure is directly proportional to the temperature. That is all from me. Thank you.